Hello again. I hope the coffee break was good. So let's continue. One of the serverless promises is to help construct and maintain scalable applications very easily. But I can't imagine how difficult it is, or it can be, to deploy and provision such the infrastructures we saw this morning, such as Lego or PostNL. To do that, we know tools like infrastructure as code to help us do that. But the drawbacks are that we have to know the language. We have to learn these tools, which can be very difficult to learn. And I was very surprised and excited when I first heard about infrastructure from code. The idea is that you build your application, so just the code, and at deploy time is the cloud provider that inspects your code and provision itself all the underlying infrastructure that you need. So very interesting. And today, we have another AWS Serverless Hero to talk about that. He is well aware of this kind of events since he organized AWS Community Day Turkey, AWS ServerlessDays Istanbul, and ServerlessDays Virtual. So please welcome Emrah.
Thank you for this introduction. So yeah, where is my clicker? Yeah. Before even diving to this, I'd like to just give you that, at the end of this talk, I just want you to get away with this. You will be able to just write your code after listening to this talk. So while I have my back with you, can I also take a selfie? Hey, say hi. So because I'm just doing another Twitter thing, that's why I need that. Okay, so today I'm going to talk about serverless as it was meant to be or it should to be. So let's start with discussing about what does serverless mean to you actually now? Because when I say this, everyone says there's something different. And when I research it on the internet, it is actually quite different as well. So Cloudflare just focusing on just backend service, pay-per-use. And Red Hat is about no need to manage servers. Wikipedia says it's about again, no need to manage servers. And Cockroach is focusing on the scale to zero. And AWS is talking about no need to manage the servers. And Microsoft is similar. And also Google is also talking about scaling to zero. So their first one sentence definitions. For me, what serverless should be, meaning is, it should be you don't need to, no need to manage servers, and you don't need to do anything about patching them, securing them, and it should be scaling down to zero and up to infinity, and it should be highly available, of course, and it should be pay-per-use, of course, and kind of a new thing that it was not the first definition of serverless when it was first announced. But the event-driven is now just maybe the first thing that we should think about serverless. So this is the definition of serverless for most of the people like me. But you would expect building serverless architectures be a little bit easier, or make a better developer experience, right? So I'm sure that you are bored of seeing this, but this is when you want to build a real application with serverless, you need to actually build up something really strong by selecting the right services, by connecting them, by coupling them. So you need to be really thoughtful and understanding of you need to have the a very best understanding of how a services would work in AWS or in any other cloud infrastructure. So by the way, most of the examples that I'm going to give this today on AWS because I'm most knowledgeable about it. But this picture would look similar in other languages and other cloud vendors as well. So you also need to select from day 0 maybe, which service to use. Like if you do some eventing, would you select like event bridge? Would you select SNS? Would you select like Kinesis and so on? Like it is like lots of decisions still to be made. So it is not actually the experience that we would expect, right? So it's not increasing that much. It's increasing. Like I'm not saying that it's decreasing the developer experience. It's increasing, but it's not where we want to go. So there is this new category emerging, like this kind of a quote from Samdan. He was the developer advocate for Netlify and AWS Amplify. And like he also worked with some other company with FI at the end. But like he's now running the developer experience newsletter. If you are not registered to it, like I really strongly recommend. He says that in this new category, the runtime and the cloud infrastructure will converge into the same thing, and he's calling it self-provisioning runtimes. I'm calling it, like we are calling it, infrastructure from code. But the idea is simple. So your runtime will allow you to provision and manage the infrastructure that is required for it. So we are going to discuss about this. But let me just like a little bit talk about myself. Actually, I've been introduced really nicely, but like let me just go over this. So I'm coming here from Ankara, Turkey. So I'm living here. I'm working remotely for Ampt from there. All the other team members are in America, so you can understand that I'm a night owl. This is my son. I'm a dad to this guy. It is like taking the very nice quality of time. And I'm a serverless hero since 2020 for 3 years almost. And I'm also an organizer for AWS Community Day in Turkey. We had the AWS Community Day Turkey in last month with more than 400 people. And needless to say, you are all invited for the next year. It will be even bigger. So I'm also a fresh entrepreneur with Ampt as their head of product. I'm working on the infrastructure from code. So rest of my talk, I'm going to talk about like what are the responsibilities of the developers for serverless. And I will just talk about like this configuration over code problem that I regard as a problem. And then we will talk about what is actually this infrastructure from code thing is, and we will look at like what is the state of the infrastructure as now, and what could be the feature holding for us with infrastructure from code. So back in 2017, like it is almost like 6 years ago, Werner Vogels, Amazon CTO, if you don't know about him, told that, like on the stage, all the code you ever write is business logic in the future. So we are not quite there, right? So we are still responsible for selecting the right infrastructure, as I said, and just coding it. And like you should also code the business logic as well, of course. And you should actually create and build the deployment pipelines using any tools that you prefer like GitHub Actions or like maybe Jenkins. And then like you should be able to instrumenting actually. Luke's talk was great about like putting an event ID on like in metadata for every span and so on. You should be instrumenting the application, and you should get ready with observability with using some tool or nothing. And like you should also be caring about security and compliance of your application. So this is still your responsibility, and this is kind of just not writing business logic only. And there are also some problems in serverless, which kind of makes it a little bit like I don't want to say, because I'm a serverless, I don't want to speak so much negatively about it. So that makes the things a little bit harder, let's say. Like this, like when I want to say this, so like when you do a serverless local development, it is actually, like when you want to do local development, you are just maybe sometimes mocking some services. Sometimes you are using something like local stack just to make the local replica of the cloud services, and like it is kind of still a pain to build something locally. So like if you ask my idea, I never recommend doing local development with serverless. I'm gonna come what I recommend next. So it should be like a ideal stack isolation should be about every developer should be able to get their own AWS account, and in this AWS account they can actually have different stages of different microservices mimicking the production. And every PR or feature branch should have its own stage so that you'll be able to like work on that, maybe test on that, maybe collaborate on that without actually breaking your own local, your own AWS environment. Like for me, a local environment is an environment that's just connected to your AWS account with SSD, whatever, like maybe using something else. And every stage of every microservice should have its own account as well. So for any type of a failure, it's a very wonderful world, considering that it's all serverless. So there are some serverless services which are actually not quite serverless, right? So the biggest one, the ones that we actually love talking about much is the OpenSearch. So for using some the serverless services, you need to be able to pre-provision. You need to pre-provision some resources so that actually you can start from it's not scaling down to zero. So when you want to use Amazon OpenSearch, for example, for every stage you should pay almost 700. It is not possible. So you better mock this or just assume that it will be there. So the another one is Neptune. It's about it's quite a little bit cheaper, but it is considering that you have hundreds of developers, it's not possible to use graph database on your every stage that you have. So this ideal stack isolation becomes not really possible due to not really serverless, so-called serverless services. It's not okay. Okay. Let's say that we are really we don't need these services. Many of the use cases don't need these services. But now then we will need to write a lot of things with infrastructure as code, right? Like using CDK, maybe using SAM, using CloudFormation, and using Terraform, whatever. So this is again creates another kind of lots of people likes this. Lots of people like using configurations over code, and I also like it actually, to be honest. But it's also kind of making your application a little bit bifurcated. It's the sum of the business logic is in your Lambda functions inside, and some of the business logic is in the let's say the CDK. So you are doing how do you handle the errors using configuration, infrastructure as code files. You are using it for managing failover. You are using it for transforming data. These Lambda-less serverless architectures are so popular that you get if you are transforming data from somewhere to another, you don't need to use Lambda. You can just use Event Bridge for that. It's quite cool. When you look at it from that perspective, and you are also orchestrating and I'm always failing to pronounce this word, but choreographing the cloud services. So it is really cool. But you are kind of I have a Lambda list. I'm just configuring this from my infrastructure as code provider. I'm just configuring some retry counts and how does it work. And I'm also coding my business code in my Lambda function. So your business code becoming bifurcated in different places. So it really reminds me of sort procedures back in the day. So when you have the stored procedures, if you are familiar with stored procedures, when you join a company, it almost takes a year to discover that there is a stored procedure somewhere. So it's always when you put it on the other places, it kind of becomes not really visible for people. So these all results reduce the developer productivity that I was mentioning since the beginning. But what is the developer productivity? So I'm talking about what does developer productivity mean to me? And it means high fidelity development environment. As I say, every developer has its own development environment, which is quite like production, which is really mimicking what's going on with the real life, not with the traffic load, but maybe with the real applications. And it should be quick to set up this environment. So when you get up and running with something, it should be really quick to start working on the application. And I know that it's not quite the case for many situations. And being able to do integration testing should be easier. So running tests between services, between stages, between real services, is still a problem in 2023. And just to summarize, time spent on value should be time spent on setting up the infrastructure or setting up the thing. So I don't know, maybe I can just ask at this point, like, do you think that you are spending, like, who is thinking that they are spending too much time on infrastructure setup? Oh, not much. So, so like you should be spending more time on value instead of just setting up the infrastructure for every stage. And this is actually what infrastructure from code is, promising for us. So it is actually a new paradigm. It is automatically inferring the infra requirements from the business logic. There are different ways of doing this. I will commit this, but this paradigm actually gives you a tool set for provisioning, managing, and optimizing. This is actually more important. So optimizing, it's not a static architecture that like you are building with infrastructure as code. It's about like an architecture that can change with your will or without your will, that you know, that you don't know, with this stuff. So we can just like infrastructure from code providers increase and decrease the memory of your serverless function because it's kind of reducing, it's kind of using more than we would expect. And it can switch to containers, like in the Amazon Prime case. So like if the traffic is so consistently so high, maybe Lambda is not the tool that you would actually need to trust. So you can switch to containers, and infrastructure from code can do this on behalf of you. And you can also, like, let's say that like a region is just collapsed for some reason, for floods, for Amsterdam. Is there anyone from Amsterdam here? So you can switch over to other regions when a region is in a trouble. So like how this is done. So this is an example of infrastructure from code, from Ampt, and it is like this. So in this picture, what you are doing that you are defining an API using an SDK, and you are setting a value to a database. So it's all this. Like this is the architecture that it actually generates at the background for you. It creates an API gateway with Lambda function and DynamoDB, and it is like working synchronously. And it can also work asynchronously, by the way. And it is like it's giving up this architecture only by this code. So let's look at how would it look with CDK. Like by the way, ChatGPT wrote this. No, I didn't. So it might be wrong. So don't judge me. And this is how it would look like with CDK, and how it would look like with AWS SAM. And like this is quite long, right? This is like it's a very simple example. I know that you can just boilerplate this, but it is still a lot of work to do. So this paradigm believers, let's say this new people in the room, is believing that cloud is the new computer that we should better utilize. And the way to utilize it is with infrastructure from code, which we regard as the new operating system, with its new primitives. Like in the earlier day of computing, our primitives are still kind of integers and strings and like whatever. But in the cloud world, we have a higher level abstraction primitives, which are APIs. So I just want an API. Like you are defining an integer, you are defining an API just by writing code. I'm just like want to define some scheduled task that will run every Friday to remind me about like what to do in the weekends. It would be nice, right? So like the events, like the event-driven systems and the databases and blob storage like S3, WebSockets. So this should be all the primitives of building a new application without actually thinking about the background of it. So in my opinion, this is the true promise of cloud, writing only application code without drowning in YAMLs and anything similar like Terraform files and so on. This is the infrastructure from code vision. This is not, when I say vision, this means actually that like it is not completed yet, but this is where we want to arrive in some time. So self-provisioning is done. So it is like actually, we are just like with zero config, you can provision a service. And self-instrumenting is in progress, I can tell. So like while you are building with infrastructure from code, this doesn't mean that you don't need anything about like why your service is taking long. So like your service should still be instrumenting itself so that actually you can look and see what's going on in your service. And it should be self-instrumenting so that you can just look at Datadog, let's say, and say, hey, yeah, infrastructure from code, but still, I'm responsible about like my service returning fast to the customers. Self-documenting, it's like, you should be able to see what is the infrastructure it's actually created and how they are connected to each other. And self-testing is actually quite possible for now. Like you are just like creating an API points and you can make the service to generate a test for that. And auditing is another thing that should be unlocked in the future. It should be actually good for security and compliance. And I say like it should be self-managing. It should be always like deployed to managed services rather than virtual machines, so that actually it will be managing itself for the future. And it will be, like as I say, optimizing. So if Lambda is not the right choice, there is a better choice, AppRunner. If AppRunner is not the right choice, there is a better choice, Fargate, and so on. But like our limit is self-managed services. So we cannot go to EC2 from there. So it's self-upgrading. So let's say that like this is kind of that we like to achieve. But let's say that like you like to run this function on edge rather than on cloud. So you can just upgrade this to edge in possible parts, so you should be able to run this. So when we go back to the developer responsibilities, it's really like what Werner Vogels was describing in 2017. You will, in this world, just write the business logic like this. So, but there are still limitations of infrastructure from code. So there are like, most of the limitations are kind of culture, like it was for serverless 7 years ago maybe. It is like people are used to touch the knobs, even if they don't play. Like I'm just interviewing with lots of developers about this. Hey, they say, oh, you are just taking away all the control from me, and I'm used to change to something, and I'm asking them like, how often actually you change like the memory of a Lambda function? I bet that we will be changing it quite often than you. So like they are like kind of have this control illusion, let's say, and they don't want to lose this. And I'm sure you also agree with them, not with me. And, and putting too much responsibility on developers' shoulders. So it is like, developers should be, like people are, complaining about it as saying that, hey, this is, makes me get rid of some responsibilities, but now I am responsible of something that I don't quite understand. I don't like it, they say. Okay, understandable. And it's like there are some SREs and DevOps people in the country, hey, this is our job. No. And there are like the still growing community. There is not much resources to check rather than speaking with people at this moment. And there are also technical limitations for now. There is not supported use cases. For example, none of the infrastructure from cloud providers can provide you a Kinesis stream so that you can actually use it for high volume data processing. There is not like kind of a machine learning part of it, but it is like the abilities that will be added in the future. And it is like, for example, Ampt is about JavaScript. You will see there is another like tools with Anchor and Shuttle, and there is nothing that covers everything like AWS would do. And like taking something from AWS to Azure is still in progress. Everyone is trying their way for that, but yeah. Let's talk about like who is doing state of infrastructure from as of May. It was from my previous slide. Sorry for that, but nothing changed. In 1 month, I can tell. And like there are solutions like SDK-based, there are annotation-based solutions, hybrid approaches, and new programming languages. So SDK-based, it is this is Ampt and this is Nitric. We are both doing. We are just giving people an SDK, and it is like you are defining the things with using these spatial by calling the SDK. And there is Model and Cloto, who are using, annotations. So here, this is like a Python code for model. They are just saying, hey, this function, by the way, is a schedule. It should be running every day. So this is how they do. This is like they define that this is something that should be creating an infrastructure using annotations. Anchor and Shuttle, this is a Go application for Anchor. Anchor is for Go, Shuttle is for Rust, by the way. Anchor is creating something with SDK and also with annotations. So they are combining it together. And there is Winglang and there is Dark, where they actually want to define a whole new programming language. They said that like we cannot just build the cloud using existing programming languages because they are not designed for that. And they invented programming languages. This is Winglang. It is like, it looks quite cool, like bring cloud. It is like bring cloud. It is like, and just like give me cloud bucket. And it sounds interesting, but in my opinion, it is quite different to get used to a new language. That's why actually we stick with JavaScript. So this is another discussion that I just want to bring up. So some of the services that we are quite often using are not built for your local. So S3, for example, it is like almost teenager now. It's teenager, but it's like a 17 years old, 16 years old. It's not for your local computer. So it is for cloud. It is designed for cloud from the day zero, and it is like natively a cloud service. And like such managed services are getting like more and more with event bridge and everything. So we have like instead of just like Dockerizing something and being able to run them on cloud. This is like what they call cloud native. There's a huge landscape, and like there's lots of applications. It's about like being cloud native is about like being able to run a local application on cloud. But native cloud is about, I'm just making it up in these days, is using native cloud services to build cloud services. So it's about like with an event-driven mindset, with using S3, let's say SQS and Lambda and so on. So what we are doing with this, and what most of you are doing, is actually native cloud applications rather than cloud-native applications. So what does infrastructure from code would mean to us? So like, by the way, it is, you should still think it about as an autopilot. So you can take the control whenever you want to, but it is actually taking you, flying you to the distant places, and it is even taking the remaining heavy lifting off of your shoulders. And it just gives you more time to provide value to your customers and more time to understand how your system is working, and you can still take the control on your AWS account when necessary. So this is the question that we are, I've been discussing this since yesterday, actually, like for quite a time. So we know that the LLMs are producing codes, and they sometimes just like screw it, but like they are kind of good at it. And there is also, a new repository by Sean Wang, if you didn't see it, small developers. So he's calling it like, he's describing what he wants. Hey, give me an API. And it should be passing and form, and it should write the things to database. And this small developer actually produces a code for him. So will we be able to trust such LLMs? Just like we will describe the application, and then LLM will produce something, and we will just deploy it right away to infrastructure from code provider. We will not even think about what this is about. So I think this could be something that we will be discussing in the future. So that brings up to the end of my presentation today. And like Ampt is still in private beta, but I'm going to allow everyone today just like enable their account to test it. If you want to look at it, you can go to Ampt website from here. And I will be happy talking with you next to, and this is how you can reach out to me. I'm always responding to DMs on Twitter, and you can reach out to me with email. And I realize that they have this after the things, but like there's also this thing that you can use to evaluate me using Swapcard. Thank you.
Thank you very much. Very interesting, and very excited to see where it goes in the future. Do you have any question about this new emerging concept? No question. Very clear.
Everyone wants to go to lunch.
Thanks for your talk, Emrah. I have a question. Why don't you consider CDK as infrastructure from code?
Well, I didn't understand.
Why don't you consider CDK as infrastructure from code?
Because it is still infrastructure, as code. You are writing code to define the infrastructure. So it is code, and it is for defining the infrastructure. In our case, you see, there is no code defining infrastructure. You just write the business code with some SDK, and it is it's understanding the infrastructure required for that. And Pulumi has something really similar to this, actually, but CDK is infrastructure.
Thanks.
Maybe with code, at S code. There was another question around.
Hello, thank you. I have a question. How do you manage infrastructure components used by multiple applications? For example, in company, we can have only one database, and multiple application consumes this database. So if your tool parse my code in each application, detect that I use these databases, I don't need to recreate these databases because it's managed by a common infrastructure tools.
So the first thing, we don't do this. First of all, this is not included. So we believe that every application has its own resources. So, but if you insist that there is some resource that is owned by a service but used by multiple services, we recommend building API for that. We recommend using, PlanetScale for most of the time. It is MySQL use case, PlanetScale or something like integrating easily with the APIs that they have, and it works like that. So we really believe in the complete stack isolation. And if you really need to do something in Ampt, let's say, we recommend about emit events and handle the events from somewhere else. So it's the inter-service communication works in this way. So they are all isolated by definition.
Hello, thank you for the talk. What facilities would you have to prevent a code change from wrecking your infrastructure?
So yeah, this is a very good question. So people are saying that, what if I delete my production database accidentally? So if you look at if you check the documentation, the old things that you are doing is about adding something new. So it's not about when you delete the line of code, while you are data.sets, and this is actually setting an item to database. Let's say that you delete this line, it will just stop setting that item. Database will stay there. So if you want to, you cannot accidentally delete anything. When something is defined, it will stay there unless you will delete whole the application. So there is no such deleting something from production use case. But everyone is asking this question, so thanks for asking it.
Thank you very much.
Thank you.